Welcome back, students. So, in this video we will discuss another mode of heat transfer, that is radiation. So, last two videos we discussed conduction, convection, and in this video we will discuss radiation. So, three modes are there to transfer heat from a hot object to cold object. One is conduction, second one is convection, and third one is radiation. Okay. So, radiation, suppose we feel warm when we sit in the sun or in front of a fire. Actually, there is no physical contact or there is no direct contact between us and the source of that heat. Means there is no direct contact between the sun and us. If you are sitting in front of the fire, there is no direct contact between us and the fire. But still we feel warm. When you sit in front of the fire or you sit in front of the fire. Okay. So, the air between us and the source of the heat is a bad conductor of heat. You know, air is a bad conductor of heat, or fluids are bad conductors of heat. Exemption cases are there, but still we can say fluids are bad conductors of heat. Air is a bad conductor of heat. Water is a bad conductor of heat. But mercury is a good conductor of heat. Because of that reason, we are using it in the thermometer as a thermometric liquid. Okay. So, commonly we will say liquids and gases are bad conductors of heat. But still, the heat will transfer from that source to us. That is by the process of radiation. Here, heat will not transfer to conduction. And in convection, by using convection method also we cannot transfer heat. So, in that particular cases, heat transfer is due to radiation. If we can't transfer heat by the process of conduction or convection, then another mode of heat transfer is there, that is through radiations. Since hot air is lighter and it will move in the upward direction. Hot air is lighter and it will move in the upward direction. And the heat will not be coming towards us. When you keep a candle and when you keep your hand above the candle, you feel it more hot, because it is due to convection of current. Convection. But when you keep the hand near the candle, just on the side, you may not feel that much hot. But still, hotness will be there. A small amount of heat will be transferred. That by the process of radiation. Heat from any distant source of object reaches us by another means of heat transfer, that is known as radiations. All objects which are heated will transfer heat to the surroundings by the process of radiation. Or we will say it like this: all hot objects, whether solid, liquid or gas, will transfer heat by radiation. All objects will transfer heat, or all hot objects will transfer heat to its environment or to its surroundings by the process of radiation. Or we can say it in another way, all hot objects, whether solid, liquid or gas, will transfer heat by the method of radiation. So, direct transfer of heat from hot object to cold object having no contact between them and without the help of any medium. Direct transfer of heat from hot object to cold object. Here there is no direct contact between the hot object and the person without any medium. That is by the process of radiation. When heat falls on an object, it is partially absorbed and partially reflected. When heat falls on an object, a part of it is absorbed by the substance and a part of it is reflected by the substance. So, and a part of it is transmitted also. The temperature of the object increases due to the absorbed part of the heat. The temperature of the object increases due to the absorbed part of the heat, not due to the transmitted and not due to the reflected part. It is due to the absorbed part of the heat. The temperature of the object will increase. All objects radiate heat to the surroundings. The higher the temperature of the object, the more is the heat radiated by it. If all objects or all hot objects will radiate heat to its surroundings or to the environment, if the temperature of the object is more, it will radiate more heat. If the temperature of the object is more, it will radiate more heat. So, that is given in your textbook, page number 42, last paragraph. When you come out in the sun, you feel warm. How does the heat from the sun reaches us? It cannot reach us by conduction or convection, as there is no medium such as air in the most part of the space between the earth and the sun. From the sun, the heat comes to us by another process called radiation. The transfer of heat by radiation does not require any medium and it does not have any direct contact between the object and the source of heat. It can take place whether a medium is present or not. When you sit in front of a room heater, we will get heat by this process. A hot utensil kept away from flame cools down as it transfers its heat to the surroundings. As it transfers heat to the surrounding. When you boil the water and you keep it away from the flame, or when you switch off the gas, after some time the temperature of that water will decrease and it will become cool. Means that object will give heat to the surroundings. That object will give heat to the surroundings and its temperature will decrease. Our body also gives heat to the surroundings and receive heat from it by radiation. All hot objects radiate heat. When this heat falls on some object, a part of it is reflected, a part is absorbed and a part may be transmitted. The temperature of the object increases due to the absorbed part of the heat. The temperature of the object increases due to the absorbed part of the heat. Now, an activity is given. I will tell you what is the activity. So, this one is about radiation, transfer of heat energy by waves in gases or in vacuum. The sun's heat reaches the earth's surface through radiation. Every hot object radiates some heat into the environment. So, here this one is a wood is heated here or burning wood. So, in the upward direction convection current will be there, but here in the sideways it is radiation. Thermal energy radiates through air from the fire. Here I have taken two cans. One is covered with a black paper, now not a polished black paper. The other one is covered with a shiny aluminium foil. Shiny aluminium foil. And I have filled the water, I have filled it with water, cover the can with lid and insert the thermometer. And insert a thermometer. Place the cans in the sun, note the temperature, and after 15 minutes, after 1 hour, 2 hours, note the temperature of the water inside the can. Okay. So, activities here, you have to take two cans. One is covered with black unpolished paper and the other one is covered with silvery aluminium foil, that is shiny aluminium foil. I have filled half of them with water or it is filled with water. Now, I will close the lid. I will insert two thermometers into the can. I will note the temperature of the water and I am going to keep it in sunlight. Now, I will keep the can in the sunlight. Now, we will record the observation, means we will take the reading of the temperature of the water using a thermometer. Okay. You can see that the temperature of the water in the black can will be more than the temperature of the water in the white can. Okay. Temperature of the water in the black can will rise or will be more than that of the water in the white can. Now, what will I do is, so from this one you can you will get an idea that black objects will absorb more heat. Black objects will absorb more heat. Black objects will absorb more heat. Now, so at this time the temperature of the water in these two cans are different. So, I will boil it to a particular temperature, same temperature. Okay. I will boil the water in the aluminium can. I will boil it to the temperature of the water in the black can. Now, both the temperature are same. Now, I will keep it in the shade. Now, I will keep it in the shade. So, when you keep both the cans in a shade, and the same method we will follow, we will note the temperature after 5 minutes, 2 minutes, 10 minutes, 15 minutes, like that we will note the temperature. Then we will get an idea that when the cans are placed in the shade, the black colored can cools down faster. The black colored can will cool down faster. So, from this experiment, from the same experiment, you will get two ideas. First thing, black color will absorb more heat. Second one, black color will reflect more heat. Black color will reflect or radiate more heat than the white object in the same period. Black objects will absorb and radiate heat than the white objects in the same period. When you keep these two cans in the sun, the temperature of the water in the black can will increase. temperature in the water temperature of the water in the black can will increase, and now I will boil it to a same temperature, and I will keep both the cans in a shade, and I will note the temperature again. So after some time we can see that the temperature of the water in the black can will cools down faster, or the temperature will decrease faster. The temperature of the water in the black can will decrease faster, or is decreasing faster, or we will say it in another way, the water in the black can cools down faster. So two ideas we will get with the same experiment. One is black objects absorb more heat. Second one, black objects radiate more heat. Black objects radiate more heat than white objects in the same period of time. Suppose two t-shirts are there. One is white and one is black. They are in sun. They are exposed to sunlight. Which one we feel it warm when you touch it? Which one will be hot for us? Black t-shirt, because that will absorb more heat. Now applications of this one, here this is a beaker, it's covered with black paper. This one is a normal glass beaker. It's filled with water. Now both these beakers are kept in sunlight. So what will happen after some time when you note the temperature? The water in this beaker will have more temperature. When compared to this one, water in this beaker will have more temperature. Here the applications. Solar heating devices, that is solar cooker and solar water heaters, are painted in black. Solar water heating devices are painted in black. Solar cooker, solar water heater, all those things are painted in black. What's the reason? Black color will absorb more heat. Black color will absorb more heat. Then in places of hot climate, it is advised that the outer walls of the houses will be painted white. In places of hot climate, it is advised that the outer walls of the houses be painted white. White color will reflect more light. White color will reflect more light. So we don't feel hot inside that house. Okay. Bottom of some cooking vessels are painted in black. Bottom of cooking vessels are painted in black. Black color will absorb heat. So that process of cooking will be faster. Okay. The cooking process will be faster. Then the backside of refrigerators are colored with dull black to radiate more heat effectively in order to cool down the refrigerator pipe. You can see the refrigerator backside pipe is, its backside of this refrigerator is colored with dull colors or dull black. That is to radiate more heat so that we can easily cool down the refrigerator's pipes. Then, so what kind of clothes we will wear in summer? In summer we will wear light colored clothes. Light colored clothes, because it will reflect the sunlight. So what about in winter? In winter we will wear dark colored clothes. In winter we will wear dark colored clothes, because dark colors absorb more heat and light colors will reflect more heat. The same activity is given in your textbook, activity 4.11. Why is it more comfortable to wear white or light colored clothes in summer and dark colored clothes in winter? Dark surface absorb more heat and therefore we feel comfortable with dark colored clothes in winter. It will absorb more heat. Light colored clothes will reflect most of the heat that falling on them and we feel it comfortable during summer season. Okay. So, radiation, that is a process of heat transfer in which there is no physical contact of there is no direct contact between us and the source of heat, or if there is no medium between the source and us. In this case, heat transfer will be done with the help of radiation. This method is the fastest method to transfer heat from hot end to cold end. Radiation is the fastest method to transfer heat from hot object to cold object. Here almost the thermal radiations will travel with a speed that is equal to the speed of light in vacuum. Okay. These radiations will travel with the speed that is equal to the speed of light in vacuum. So, three methods are there to transfer heat. One is conduction, other one is convection, and third one is radiation. In conduction, there should be a direct contact between the source and the object. Physical contact or direct contact should be there between the source and the object, then only the heat will transfer from hot end to cold end. In convection, even though if the medium is a bad conductor of heat, but still heat will be transferred from hot end to cold end. That is convection. Then third one is radiation. If there is no direct contact and if there is no medium in between the source of heat and the object, still heat will transfer from hot end to cold end, that is by the process of radiation. Okay. So, radiation will take place if medium is there or no. So, that is about conduction, convection and radiation, and in the next video we will do the text back exercise. Now, one more thing, is there a time when heat does not flow? Is there a time when heat does not flow? Heat will flow from hot end to cold end. Is there a time when there is no heat flow? Yes, when both objects are having same temperature. When both objects are having same temperature, the heat will not flow from one object to another. Yes, if two objects are at the same temperature, no heat flows from one object to other. That is here. Water is also at 95 degrees Celsius. This rock is also at 95 degrees Celsius. So, heat will not transfer from water to rock and also from rock to water. Heat will not transfer if the two objects are having same temperature. This is about the state of matter. Okay, just I will explain to you. Yeah, this one is, suppose you consider water. 0 degrees Celsius, till 0 degrees Celsius it is in the ice form, that is solid. So, when you give temperature, it will melt, the ice will melt and it will come and water will be formed. Ice will melt and water will be formed. So, it will take a small amount of heat to transfer the state from ice to water. But there will not be increase in the temperature. At that time, there will not be any increase in the temperature, but that heat will be absorbed to change the state of the matter. That heat will be absorbed by the ice to change the state of the matter, that is from solid to liquid. But there is no change in the temperature. Then again the temperature will increase, that is the whole thing is liquid, water. Now at 100 degrees Celsius, the water will start boiling. At 100 degrees Celsius, the water will start boiling. If you are heating again, what will happen? The heat will be absorbed, but the temperature will not increase, but that heat is used to change the state. If you are heating again the water at 100 degrees Celsius, the heat will be absorbed by it. The temperature of that water will not increase, but that heat is utilized to change the state. That is from liquid to gas. Liquid to gas. So in the beginning of the chapter I told heat can change in state. Heat is used to change the state of the matter. That is this one. Okay. When water boils at 100 degrees Celsius, if you are heating it again, the temperature of the water will not increase, but it will absorb the heat to change the state of matter, that is from water to gas. The same thing here from ice to liquid.